What if I gave you a pill with the following property? The active ingredient has been diluted to the extent that not a single molecule of the active ingredient remained in the pill. Would you be impressed with the therapeutic potential of this pill? What if I told you that the idea behind why this pill works derives from a more than 200-year-old practice on which more than $3 billion a year is spent in the US? Homeopathy was invented back in 1796 by Samuel Hahnemann. It is based on the idea that like cures like. The idea that a substance that causes symptoms of a disease in healthy people actually cures sick people with those same symptoms. Once a substance is chosen, it is repeatedly diluted, believed by Hahnemann to activate so-called vital energy in the substance. For example, in homeopathic lingo, a 2C dilution means that a substance is diluted to 1 part in 100, and then again a second time. Dilutions at more than 12C, or 10 to the power of 24, would be unlikely to contain even a single molecule of the original substance. So the plausibility of homeopathy is basically zero, as some fundamental laws of physics and chemistry would have to be broken if homeopathy were to actually work. That means the prior probability of homeopathy should be considered extremely low, and it should take a huge mountain of strong evidence to convince any reasonable, impartial person that there's anything to this. So what evidence is there that homeopathy works for anything? Let's apply some basic epistemic tools and principles of evidence evaluation that I discussed in earlier videos. Let's do a little tour of the scientific literature on this topic. As previously mentioned, randomized controlled trials, or RCTs for short, are the gold standard of study design, specifically placebo-controlled double-blinded RCTs. And even better, if we can locate meta-analyses and/or systematic reviews of these trials. So what turns up if we go looking for these? Specifically, what is the quality of the evidence? And what conclusion is suggested by the weight of evidence? If you search Google Scholar, PubMed, or another search engine of the scholarly literature, you will quickly become overwhelmed. There are a lot of studies. We can ignore the observational studies, as they will be plagued by confounding issues. There are also a ton of randomized controlled trials and even quite a few meta-analyses and systematic reviews. Let's focus on these to see what the overall picture of the literature looks like. One of the first systematic reviews is from 1998, co-authored by Edzard Ernst, a specialist in researching alternative medicine. It analyzed 8 placebo-controlled trials for a specific homeopathic remedy, finding that its efficacy is not supported overall, and that the methodologically strongest trials indicate a lack of demonstrable effect. The poorer controlled randomized controlled trials have sometimes shown positive effects, while the most rigorously controlled trials don't show any effect beyond placebo. This is what Lind et al. Found back in 1999, concluding that, quote, there was clear evidence that studies with better methodological quality tended to yield less positive results, end quote. Ernst conducted another systematic review of placebo-controlled RCTs in 1999 on homeopathic prophylaxis, finding no effect beyond placebo. And yet another in 2001 for the treatment of osteoarthritis, finding a positive effect, but again provided caution about the methodologically weak and study design issues. Jonas et al. In 2001 systematically reviewed a wider range of clinical trials, finding that most studies were plagued with all sorts of methodological issues, precluding any conclusions about its efficacy. Pilkington et al. In 2005 systematically reviewed the literature on homeopathy for depression, again finding a lack of well-designed trials to support any claim of efficacy. A few earlier reviews did find slightly positive effects of different homeopathic treatments above placebo. However, even these admit to methodological issues related to confounders, such as a lack of adequate blinding. Some of these were rather equivocal, like a meta-analysis by Lind et al. From 1997 that did not totally close the door to a possible effect beyond placebo, but which also caveated that there was insufficient evidence of any clear efficacy for any single condition. Yet, homeopaths celebrated this study as proof of homeopathy's efficacy. Go figure. Later reanalyses of this data suggested that this positive effect was due to publication bias. See my previous video, 5.3, on methodological problems in science, in which I discuss publication bias. This issue of publication bias is very common in alternative medicine treatments. Additionally, there are specific alternative medicine journals that are, unsurprisingly, more likely to publish positive findings of such treatments, as this 2005 systematic review found about homeopathy. Edzard Ernst again decided to thus conduct a systematic review of systematic reviews in 2002 to try to understand even more cumulatively what the weight of evidence looked like. He concluded that the totality of evidence does not support the efficacy of homeopathy beyond placebo effect. In perhaps the biggest and best effort to date, in 2005, Shang et al. Conducted a meta-analysis of over 100 placebo-controlled RCTs of homeopathy. The largest trials of the highest quality failed to produce any effect beyond placebo. Another meta-analysis from 2017 by Matthew et al. Similarly found that although there was a statistically significant effect overall, an analysis of a subgroup of the strongest evidence found no effect beyond placebo. Cochrane, who I mentioned in video 5.1 as a trusted, independent source that conducts systematic reviews of the literature, has reviewed the homeopathy literature many times over the years. Their repeated conclusion mirrors the evidence I've just covered, that the methodologically strongest studies do not demonstrate efficacy of any homeopathic remedies, from asthma, to dementia, to irritable bowel syndrome, to ADHD, to influenza. Edzard Ernst did another systematic review of all these Cochrane systematic reviews to attempt to synthesize what the best available evidence indicates, concluding that it fails to show effect beyond placebo. Likewise, numerous government efforts to synthesize the evidence have concluded there is a total lack of evidence to support homeopathy, underscoring a pretty uncontroversial scientific consensus among the scientific community. To put it frankly, homeopathy is rank pseudoscience. So if the best available evidence fails to find any beneficial effect of homeopathy beyond placebo, what explains the perceived positive effect that's been found in some studies? Due to the low methodological quality of so many studies, with issues like a lack of proper blinding and a lack of adequate randomization, and publication bias throughout the literature, there are all sorts of non-specific effects that can creep into the supposed treatment effect. One investigation found that the consultation process that homeopaths offer their patients can be responsible for the supposed therapeutic effect. Other non-specific effects that I mentioned in the previous video could likewise be responsible, such as 1. Regression to the mean, and 2. Measurement error due to response or observer bias. With weakly controlled trials, all sorts of confounding effects can enter into the equation and create the illusion that an intervention works when the measured effect reflects a host of other factors. Okay, so given this pretty clear-cut evidence that homeopathy is bogus, why does its popularity persist? The anecdotal fallacy is powerful and can often lead to the logical fallacy called post hoc ergo propter hoc, translated as after this, therefore because of this, as well as to mistake correlation for causation. If we're suffering and we receive some treatment or participate in some intervention or activity, and we then improve, it will seem like that treatment or intervention was effective, even if it was completely useless. At the individual level, it is often impossible to distinguish between a useful treatment and a useless treatment. So if someone gives you their personal anecdote, touting the supposed benefits of a treatment, keep in mind all the confounding factors that could be impairing their judgment. Furthermore, homeopathy often gets lumped in under the so-called natural treatment umbrella. So those who are duped by the appeal to nature fallacy, that so-called natural treatments are superior, are also more likely to use homeopathic products. Vulnerability is another reason that lures people to ineffective treatments. If you're suffering from some condition and there are no approved treatments, desperation can understandably lead you to venture outside the mainstream. Another issue is how drugs are marketed in general. Until recently in some countries, consumer protection laws only weakly regulated homeopathy. It is not uncommon to see homeopathic treatments like oscillococcinum on the same shelf as legitimate pharmaceutical treatments, in this case to relieve cold or flu-like symptoms. If consumers are unfamiliar with homeopathy, they can easily be misled into purchasing the homeopathic treatment. While I don't wish to venture into public policy here, a strong case could be made that this constitutes health fraud on the part of homeopathic drug companies and the drugstores that sell them. Even though homeopathy is ultimately just water, this doesn't mean that it's without risks. If people seek out homeopathic remedies instead of legitimate evidence-based treatments, they're endangering themselves. So there's a tour of homeopathy, with hopefully an accessible directive on how to assess this bizarre form of alternative medicine. We'll take a similar tour of the world of acupuncture in the next video. Thanks for joining me.